This video was intended to be a follow-up to my last one dealing with Earth curvature and how you would go about calculating the change in angle between directly looking ahead and the angular drop on each side of your vision. And in that video, there were a few confusing points and there were some comments that I wanted to address. There are three main things that I wanted to address in this one. The first one, this is just an in-passing comment, particularly the horizontal angle field of view I had indicated was 120 degrees. As somebody commented, it's probably not 120, it's less than that. And I would kind of agree. There's a whole science behind that. And a lot of what we see, a lot of what we imagine we see does not occur in the eye itself, but occurs in the brain. And I would recommend that you read this if you're interested. The second point I wanted to address was my 3D model that I was using. And I had created that as a visual aid to help you understand how these calculations are being made. And one comment indicated that the angles here are not as I've indicated, but were something else. And I would tend to disagree with that because what I was trying to accomplish was that if you're looking in a specific direction like this is going to be your eye level right here, the top of this line that extends like this. But if you're looking down on the surface of the Earth like that, the bottom of this rectangle that you see like this here, that represents a line that is parallel to the top one. And so the whole point was to use various trigonometry equations to be able to calculate what these angles were. I understand it wasn't entirely clear, so what I did was I modified my model slightly to include only on one side. I didn't put it on the other side, but you can see that I added an extra one over here. And this essentially shows that this angle is the same as this angle. That brings me to the third point, which is what was the point of the previous video. The main point of the previous video was to show all of these calculations so that you could see and visualize something by measuring a drop on the side of your house. I was kind of hoping that if you could see the size in millimeters that the line would curve by superimposing it on the side of your house, just how difficult it would be to see the curvature of the Earth. And that this is clearly not a straight line, because if this was a straight line, this would be zero. This angle drop would be zero, and the drop in meters would be zero, the drop in millimeters would be zero. So to help illustrate that point further, I've also created an animation with the intent of showing this on a computer screen, on a tablet, or hopefully on something really large like a 60-inch TV. And the idea is that the distance that you would stand to the screen is represented as a ratio of its width, and that is derived from the horizontal field of view that I used to render this animation. So I used 90 degrees here. And if you've got a TV screen that's 1.328 meters wide, so from here to here, like this, and you're standing over here looking at the TV in this direction, this represents 90 degrees. You would be standing 0.664 meters, which is half of this. And so what I did was I created an animation that shows an ascent straight up from 10 meters to 300,000 meters. And so this is the point that I was trying to make. How high do you have to be before you start to see a curve? this is probably one of the best case scenarios. There's a very clear contrast between black and yellow, but keep in mind that if you're looking out of an airplane at 10,000 meters, or probably even closer to 11,000 meters, that this represents a 90-degree field of view. An airplane window is about 9-10 inches wide. So half of that, to get the same field of view out of an airplane window, your face would have to be about 4 inches away from the glass. And the other thing too that you have to keep in mind is that the haze and the moisture in the air will tend to bleed with the ground horizon. So it'll become harder to actually see the distinction between air and ground. So that was basically it. Thanks for watching.